Okay, I know there's not some people aren't here yet, but we gotta get going. We got a lot to do tonight. We actually have 3 sections we have to do. One, which is kind of one of those things you'll probably remember and go, oh my gosh, I remember that. I never liked it very much. I hope not, but we'll see. If I say the word quadratic formula, does that make anybody cringe? Yes. Yeah, a little bit. Well, we will try to go through it nice and slowly, and we'll make it. We'll make it through there. On the test, overall, very good job on the test. You guys did, for the most part, pretty good. I think the average was 92 out of 100. Out of 100, I guess out of 105 if you did the bonus and got everything else right. But really, it's only out of 100 points. The one question that tricked up some people, and I was talking to Dave about earlier, the recipe one. And I guess I didn't explain this one very well, maybe, and so I apologize about that. But this is one of the most useful things we'll do in here, right? Quadratic equations. You might not do quadratic equations the rest of your life, right? If you're not in a math or sciencey type major, but you'll make recipes for the rest of your life, and you'll have to all of a sudden your kids will have this big party, and you'll have to double or triple the recipe for something, right? And you have to know how to do that because you don't want to accidentally do that. As a side story, quickly, my mom once made a bunch of pies. She made these grape pies. We've ever had grape pies. It's actually pretty tasty. It's kind of like grape jelly, but in pie and sweeter and whatever. But she made these grape pies, and she did it at a neighbor's for some reason. Well, turns out she brought them back to the house, and we had some friends over. And one of the friends had this 11-year-old daughter, and she's the first one who took a bite of this pie. And she takes one bite, and she says, "This is terrible," right? And her dad looks at her and is like, you're at somebody else's. Why are you being rude? So my dad takes a bite, and he goes, "This is terrible." And my mom looks at them both like, well, what happened? Turns out my mom actually used 2 cups of salt instead of 2 cups of sugar. No sugar, just 2 cups of salt. So it was pretty terrible. We didn't eat the rest of that pie. But anyway, okay. So anyway, if you want to do this, I was trying to figure out a better way to explain this. But if you're going to double a recipe, what do you have to do? You have to do 2 times whatever the amounts are, right? That's doubling it. Okay? Really, you're going from 1 to 2, and then you're just multiplying that 2 times however much the recipe calls for, right? That's what you're going to do. You're going to do whatever it says. If it's 1 cup, or let's say it's 3 cups, and you're going to double it, you're going to do 2 times 3 cups. On one of the tests, it went 3 dozen to 8 dozen. I forget what the other one was, but it was 3 dozen to 8 dozen. Isn't that the same as saying you're going, instead of going 1 to 2, which is 2 times the amount, basically 2 divided by 1 times the amount, isn't it saying you're doing 8/3 of the amount? 8 divided by 3 times whatever that amount is? That's all there is to it, right? So that if you think about it, when you go, oh, okay, I get it. So what was the other one? Who had the orange one? What was the ratios?
1 3/4 cup sugar.
Yep.
3 dozen pumpkins.
Well, it was still 3 dozen. Was it all 3 dozen to 8 dozen? I think it was. Yeah. Well, anyway, 3 dozen to 8 dozen. It's going to be. You just got to think of it like this ratio. And it's one of those things. Again, it's one of those things you will definitely do this again sometime in your life. Pancake recipes are the big one, right? If you know it's the thing says it makes 28 pancakes, and it's you and your spouse eating pancakes, you're not going to make 28 pancakes, right? You're going to make whatever. You're going to have the recipe or whatever. So instead of going 1 to 2, you might go 1 to 1/2, right? Well, what are you going to multiply by? 1/2 in this case, right? So you and your walkie-talkies again. But anyway, so that one, I was a little sad that some of you guys missed that one. But overall, very good job anyway. Where'd you go, Chad? There you go. All right. Amy, there you go. Good job. And Christine. All right. So the first thing we're going to cover tonight. Oh, by the way, one more piece of business. First test was yesterday. Next test is actually, believe it or not, next week already. I know the class is compressed so much that we have a test next week already. There's just not enough time to get them all in doing it every other week. But right now it's scheduled for Saturday. Would you rather we do it on Sunday? Give you a little extra time to study, extra time to ask some questions on Saturday, maybe?
Yes.
Okay, we'll do that. We'll just make sure. I'll just do 2 sections on the day before or whatever on Saturday. So we'll do that. I do have another practice test that I'll hand out a little bit later, so you can look at this. And the answer key is already online, and you can study that. And just like last time, if you didn't notice, this test was pretty much exactly like, except for maybe one question, the previous test, the practice one I gave you. So you're going to see very, very similar questions. Okay, they won't be identical, but they'll be very similar questions. Okay, any comments or questions on that? Okay, all right. So the first thing we're going to do tonight is the same stuff we've been doing with equal signs, except now we're going to do them with inequalities. Okay, in other words, we're going to do them where you've got something that is less than or equal to something else, or something is greater than or equal, or greater than something else. We have to do a couple things with this. We have to actually do the algebra for it, which is exactly like the algebra we've been doing already, except for one key difference, which is very easy to remember. And that's the only big difference. And the other thing that we're going to do is we're going to actually graph these inequalities. Because, for instance, if I said something was, let's see, if I said that you were going, let's see, there was, I don't know, a pencil costs $3, or it costs less than or equal to $3. That's the cost, less than or equal to $3. Okay? If I was going to, that's like a range of numbers, right? It could be $1 or $0, well, $0.2 or whatever. Let's assume that somehow you could have negative dollars in this. If I wanted to graph this on a number line, 1, 2, 3, 1, 2, 3. If something's less than or equal to 3, it's going to be everything this side of 3 on the number line, right? Well, this is how you're going to graph it. If it is less than or equal to, we have a special symbol for the end point, which happens to be a filled-in circle. Okay? That means less than or equal to. So if you see a graph like this, and you can shade this in more if you want to or whatever, that means that this line is showing, you can put 4, 5, -1, -2, whatever. Then this is showing that the answer is less than or equal to 3. If it's just less than 3, okay, you actually change that to an open circle like that. Okay, pretty simple when it comes down to it. Okay, now linear inequalities, and again, linear is one variable. A lot of times it's x, sometimes it's other variables. Okay, and we have these symbols, and I'm going to write some of these out here. Okay, in English, okay, if you say that x is at least 5, okay, in symbols, okay, this is x is greater than or equal to 5. Does that make sense? If it's at least 5, start at 5 and go more. Okay, so it's at least 5. If x is at most 5, it's going to be the exact opposite, right? X is less than or equal to 5. Okay. You can also write if x is between, say x is between 3 and 5, you're going to have x in there. You're going to have 3 on one side, 5 on the other, and you're going to say less than or equal and less than or equal. Between 3 and 5. Okay. Obviously, if you have x is less than 3, that's going to be x is less than 3, or x is greater than 3. Then you're going to have x is greater than 3. So those are the key terms we have to know for these. Okay, the key terms. All right, let's do a nice word problem on this stuff. Okay, I'll write the word problem down here. Word problem is a rental car company. Rental car company charges, You think if I changed that and I said hertz, and then when I put the video online, I called them up and said, hey, I gave you a shout out, they'd send me some money? They might. Hertz charges $100 a week. $100 per week. Okay? And 25 cents, and I'll write it like that, $0.25 per mile, okay, to rent a car. To rent a car. Okay? You can only spend, you only have $330 to spend on the rental. Not including gas, I guess, and taxes and all that kind of stuff. Okay? How many miles can you drive? Now this looks a lot like regular algebra problems. Okay? And in fact it is, but there's just a little difference here because you could drive 1 mile, or you could drive 2 miles, but you can drive all the way up to some amount of miles. That's what we're trying to figure out. Okay? All right, so how are we going to start this? What's that? What were you going to say, Chad? Subtract the 100 from the 330. Let's do it a little more systematically than that. Okay? Let's try to get it into a form. So the first thing I'm going to do is circle some of these things that we're going to need to know, right? 25 cents per mile, etc. Okay, so, well, yeah, so where's my variable in this case? I'm trying to find how many miles. So what variable should we use? Yeah, we should, well, which thing is going to be the variable? Miles, right? So you could use m or you could use x. Let's use m. Okay? M equals the number of miles, okay, that you travel. Okay? All right. Now, I like where you were going with that, Chad. You're going to say, let's start with the $100 part, right? And we'll get to the 330 in a little bit. Okay? The $100 part is the key one because you're going to at least pay $100 because it says $100 per week to rent a car. How many miles can you drive? I guess it should say in that week, right? Because we're not going to just say 1 week, we'll say. Okay? So you're going to start out, you're going to say what? $100 plus what? What's that? Yeah, 0.25 because that's how many miles or how much it costs per mile. So you're going to say times the number of miles. Okay? And then that number, now you might say equals. You could say equals 300 and, sorry, not, yeah, it's going to be 330, right? 330. But what's the problem with saying equals? Does that count driving 1 mile or 2 miles or 3 miles or 5 miles? No, you could drive any of those miles, right? So what's it going to be instead of equals in this case? Less than or equals, okay? So it's going to be a little less than or equals sign. Okay? That's the only thing that's different about this problem, which is pretty nice because it's just algebra from now on. Just pretend that was an equals if you want to, if this kind of confuses you, right? OK, so what do? We're going to get m by itself. What's the first thing I would do? Yeah, subtract the 100, minus 100 from both sides. Right? And you get 0.02, or sorry, I always do that. 0.25 times m is, nobody noticed I did that wrong, by the way. Or did you? Thanks for telling me. How about less than or equal? There we go. Okay. 0.025 times m is less than or equal to 230. 230. Okay. Now what do? Divide both sides by 0.25, 0.25. 0.25, and we end up with the number of miles is less than or equal to 920. Okay? That's just regular old algebra. Nothing different about that than anything else we've done. Yeah, question?
So if we work it out a different way and put it on a paper like the way we work it out, do we get credit for it?
Well, what do you mean? Oh, if you work it out.
Say I didn't do it
Yeah,
exactly like that, but I still came over.
If you show me some work, yeah. Now, I mean, the problem with that, with just doing it whatever way you want, is that it'll get harder and you'll end up screwing it up sometime, and then I can't give you any credit if it's wrong. And we're trying to learn methods that are really important for the later stuff. So look, if you end up getting the right answer and you show me how you do it, yeah, you'll get credit for it. But I would not suggest doing that, because you'll mess up the next one that you try if it's different or it's slightly, you don't quite get it, and but if you have a different way of doing that, that's fine. Okay? Okay, so let's see. Hang on one sec.
I mean, I did it that way. I did 2, 1. I minus 1 step.
That's cool. No, you don't have to do all the different steps, but you definitely have to do enough to show me that you know how you're doing it. You can't just come out of the answer out of nowhere either. You got to at least show me that you know how to do that sort of stuff. Okay, so you do these things just like regular old algebra. Okay, there's the one difference that we haven't even gotten to yet. Okay, and the one thing you do is if you have to multiply or divide both sides by a negative number, you flip that less than or equal sign. You actually do the exact opposite. Okay? So let's do an example here. Let's see. I'll do it down here. Let's do an example. You have, well, this is not quite the algebra example, but let's say you have -3 is less than or equal to 5. Okay? On a number line, right, that would look like what? Start at 0, go to 5. Well, -3 is less than or equal to 5. Is that a true statement? Yeah, -3, if this is 0, -1, -2, -3, 1, 2, 3, 4, 5, and this is 5. It's 5, right? That's 5, and that's -3. -3 is definitely less than or equal to 5. What if we multiply both sides by -1? Right? This becomes 3, and this becomes -5. Well, now what happened? 3 is greater than or equal to -5. So whenever you're doing an algebra problem, if it comes to a point where you say, oh, I have to divide or multiply by a negative number, you got to flip the sign. Okay? And it shouldn't happen more than once per problem in general. Okay? All right. So that's that. And we'll do a couple more examples here. We've got this, I mentioned at the beginning, we've got this thing called set builder notation. I noticed I mentioned at the beginning of a couple classes ago, I should say. And set builder notation is where you have this curly bracket and then x, and then you do a colon, and then you say something like x is greater than 2. What this means is for all values of x, x is greater than 2. Okay? And we'll do some more examples of that in a little bit. Okay? All right, let's try some more of these line graphing ones, or to actually graph them on the number line. Okay? Let's say that I had, x such that x was less than 3, and let's graph that on the number line. Okay? Where am I going to go to? 3. I'm going to go to 3, right? 1, 2, 3. And normally you'll have a number line drawn out for you, right? And then I'm going to put either a circle or not yet, and then an arrow this way, because it's less than 3. And am I going to leave it as an open circle or close it? I'm going to leave it open because the open circle means less than, not less than or equal to. Okay? All right. How about this one? X such that 3 is less than x, which is less than or equal to 5. Okay? Say that was 0. 1, 2, 3, 4, 5. What two numbers am I going to put circles on? 3 and 5. 3 and 5, and I'm going to connect them. Now, these ones don't have arrows on either end because it's just 3 to 5 in this case. X has to be between 3, but not all the way down to 3, and all the way up to 5. So where am I going to put a closed circle?
In the 5.
In the 5, because that's this one. Good. OK. And those are pretty straightforward, I'd say. Last one, x such that x is greater than or equal to 3. X such that x is greater than or equal to 3. Just looks like this. 0, 1, 2, 3. Circle that way because it's greater than. And am I going to fill it in or not? Absolutely, because it is greater than or equal to. OK, good stuff? Not so bad? OK. All right. Let's try the following. This one's a little bit trickier. It involves what I was just talking about. Let's say you have, and this is what we're going to do with it. We're going to express it in this format, and then we're going to graph it. OK? Negative 3x plus 4 is greater than or equal to 9. And I want you to solve for x, write it in this format, and graph it. Okay? We are going to practice these in a little bit, too. I'll start it. Oops, I did it wrong. Oh, no, I didn't. That's right. You have to flip the sign.
Yeah, that's what I was going to ask you.
We did it. Up here, we said it before, where you said if negative 3 is less than 5, and you multiply both sides by a negative number, like negative 1, times negative 3 is less. If you can't, I mean, you can put it there for now, but negative 1 times 5. What's negative 1 times negative 3? 3. What's negative 1 times 5? Negative 5. Is 3 less than negative 5? No, it's greater than. You flip it. So you got to flip the sign. Same when you divide. When you multiply or divide by a negative number with inequalities, you have to flip the inequality. That's all there is to it. Flip the inequality itself. The actual less than or greater than or whatever. Okay? Now, look, we can plug in and we can check this if you want. If you, by the way, here's the set builder notation. X such as x is less than or equal to negative 5/3. And then you graph it on here. I know it's not directly on a number line, but between negative 1 and negative 2, negatives there, between negative 1 and negative 2 is negative 5/3. And it's less than that. So let's try a couple numbers here. OK? Let's just try a couple. Let me erase this stuff up here. And we'll try it. Does 0 fit into this range? Is 0 in the range? So if we plug in 0, we should get a number that is incorrect for this inequality. Let's try it. What's negative 3 times 0? So, OK, so we're left with 4 is greater than or equal to 9. Is that true? No. So we're good so far. This is not in the little line we drew. So we're OK. We're just checking it for now. OK. Is negative 3 in the line? It is. What's negative 3 times negative 3? 9 plus 4 is greater than or equal to 9. Is that true? Sure it is. So that one works. So you can test and plug it in. Now, if you were to do it exactly, negative 5/3, negative 5/3 times 3 plus 4. What's negative 5/3 times 3? What's that? Oops, by the way, this is, sorry, no, you're right, negative, I was looking at the wrong one. Negative 3 times, there you go, negative 5/3 greater than or equal to 9. OK, so that's going to cancel. The negative's going to cancel. It's going to be 5 plus 4 is greater than or equal to 9. Is that true? 9 is greater than or equal to 9. It is. It's equal to 9. So you can check all the different things to make sure that you got everything in the right place. Any questions on that?
How you got over here? How you got positive plus 5 on top and negative 2?
Here?
Right, yeah, on the right. Yeah. You say 5.
OK, so what I was doing here was I was saying negative 3x is greater than or equal to 5, and then dividing both sides by negative 3, because you can always divide both sides by the same thing. Negative 3 and negative 3. Because I was doing the negative 3, I made sure to circle and flip this, so I have to flip the sign.
Got it.
OK, we're good? OK, good job. All right. So that's inequalities there. Let's see, what else do I have for you? Let's try, let's see, that one we just did. Let's do a slightly easier one. 3x plus 5 is greater than 11. Do that one. Probably do this one almost in your head. Hopefully everybody got that x is greater than 2. Sorry, can't see it. Oh, yeah. Do I need to write a little bigger?
No, that's fine.
OK.
Is that like a semicolon?
That's a colon. These are just curly brackets, but I'm terrible at drawing. Curly brackets, x, such that x is greater. This means such that x such that x is greater than 2. Okay. All right, did everybody get x is greater than 2 on that one? OK, let's do another one. I'll leave that one for right now. Let's try this one. 6x minus 12 is less than 8x plus 2. I'm going to start it this way. Minus 6x minus 6x. Erase the stuff up here. Top. Can I erase the rest of this? All right. Minus 6, I get negative 12 is less than 2x plus 2. Subtract 2, subtract 2. Negative 14 is less than 2x. Divide by 2, divide by 2. Negative 7 is less than x. Be careful when you do this part. You have to be careful what you're doing with this one. You do have to flip that again when you write this part out. X is greater than negative 7. Thank you. Looking at the wrong one. There we go. This one, the way I did it, I ended up with the x on the other side. That's why when I wrote it like this, I had to flip that around. Did you do it that way too, or did you do it the other way? Did it just like this? Yeah. You could have moved the x's to the other side initially. That's fine. But you would have found that you flipped over the sign as well if you did it that way. All right. Questions on that one? I got one more for you. This one might blow your mind. Negative 7 is less than 2x plus 5, which is less than or equal to 3. Don't be scared by it. It looks funny. All you need to know is that you're really going to be dealing with just the middle. And you can't have these things facing different directions, by the way. You can't say negative 7 is greater than blah, blah, blah. You gotta, everything faces the same direction. And if you're going to subtract minus 5 from the middle, guess what? You do it to both sides. Here, negative 5 over here. Left with negative 12. I know, it's blowing your mind. I know. 2x, which is less than or equal to 3 minus 5 is negative 2. Going back up to the top. I'm going to divide both sides by 2. So I'm going to get negative 12 divided by 2, or all three sides, I should say, less than 2x divided by 2, which is less than or equal to. Unless they gave you a bad problem, this number in this case should be less than the other number. Otherwise, they would have given you a bad problem to begin with. Yeah, you have to keep it always there. Yeah. So when we're drawing this one out, it's going to be, if this was 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And you're going to go from negative 6 to negative 1, line in the middle like that. And which one am I going to color in? Negative 1, like that. Okay? I'll let you look at that for a sec. Yep. Yep. You got it. If you're going to do it to this, pretend you're really pretending you're doing two separate equations, but we're doing it all at once in this case. Yeah. And again, they shouldn't give you, you shouldn't get a problem where this comes out to be somehow incorrect. OK. All right. Any questions on inequalities? It's basically algebra with that one little twist where you have to flip the sign if you multiply or divide by a negative number. And then we got a couple other ways of writing things. Oh, I didn't write the set builder notation for this. This is going to be x such that negative 6 is less than x, which is less than or equal to negative 1, like that. OK. Any questions? Good. All right. Let's move on. OK. Now we get to go to these somewhat scary things called quadratic equations. OK? That was section 6.4. This is section 6.5 in your book. OK? Section, you guys still writing this problem down? You're good? Everybody else good? OK. Quadratic equations, section 6.5. And 6.5 quadratic equations. OK, quadratic equations. What a quadratic equation is something that has an x squared or some other squared term in it. But that's the highest power of a variable you're going to get. Full stop. The highest power you're going to get. OK? So if we have something called, like let's say we have 3x. OK? This is just terminology for a second. This is called a monomial because there's one term in there. OK? 3x plus 5 is called a binomial. OK? Anyone know what the next one's going to be? Trinomial. Right? So if you had something like x squared plus 3x plus 5, that is a trinomial. OK? Because there's 3 terms in there. OK? And 3 terms that you can't combine together at all. OK? Now, you guys all know the distributive property, right? In fact, I think everybody got it right on the test. Some of you guys put the distributive property of multiplication. Yeah, that's OK. It's really distributive property of both multiplication and addition. It's just the distributive property. But that's fine. We're going to use that to show how we actually arrive at some of these squared terms from 2 binomials. OK? Bear with me on this. Okay? I'm going to start back up at the top here. I won't erase everything quite yet. OK? If we have 2 binomials, let's say we have 3x plus 5 times x plus 2, like that. 3x plus 5 times x plus 2. Can we use the distributive property for this piece into this piece? Why not? The distributive property. All we're going to do is we're going to say, pretend this was a number by it, like just a number. We're going to multiply that number times this piece, and then the same thing times this piece, and add them together. It's distributing this whole piece through there. Watch what happens when we do that. Okay? All right, we're going to just say 3x plus 5 times x plus 3x plus 5 times 2. Did I just distribute the 3x plus 5 through the x plus 2? All I did. Okay? Well, now what can you do with this piece? Let me rewrite it a little bit. Let me just write it like this, and let me rewrite this one as well. X, what did I just use by moving that over to there? Which property? Commutative. I commuted the x from one side to the other. Okay? X times 3x, what can I do with this one now? I can distribute it again. OK? I'm going to make this a little more right in the middle there. I can distribute that again. So now this is going to be 3 times x times 3x times x, which is 3x squared, right? And this is going to be x times 5, which is 5x. Can I do the same thing with this one? Sure. 2 times 3x is 6x. And 2 times 5 is 10. So all we do is piece by piece get from the top one down to this one. Do we have, is this more than a trinomial? You would think so. But guess what? You can actually combine those terms. Okay? But before we do that, okay, let me show you what we've got here. This, I should have left it like this. 3x times x plus x times, well, you get this, yeah, 5 times x, 5x plus 3x times 2 plus 5 times 2. Isn't this the product of the first terms in the original one? Terms, T-E-R-M-S. 3x times x, isn't that this times this? And isn't this one the, which one? The inner terms? The inner terms multiplied by together? 5 times x. These two inner ones? And I say inner because they're closest together on the inside. And isn't this one the product of the outer two terms? What's that?
Isn't it foil?
It is, FOIL. And then this one is the last terms. OK? 5 times 2. OK, so what we basically did was we derived this thing called, what do we have, Martin?
Foil?
FOIL.
You're supposed to do 3x times 2. If you're going to do 3x times x, then you go 3x times 2.
Here's 3x times 2.
Yeah, but it's F-O-I-L. You got F-I.
Oh, yeah, I guess I have F-I-O-L.
Yeah.
You're right. I guess it should have been the other way around. So, yeah, I guess it doesn't really matter. You're right. So I said F-I-O-L. File. Right. Well, you can do that, too. You should rewrite all the math books. So yeah, I guess I did it a little bit backwards. We haven't quite finished this yet, though. And going back to this one right here, we can actually add the 5x and the 6x. OK? So this is going to end up being 3x squared plus 11x plus 10. And now it is our trinomial. OK? This FOIL thing, file thing, who's heard of FOIL in here? I hope everybody's heard of it. No? People haven't? OK. If you have heard of it, good. It'll be a little review. If you haven't heard of it, what it means, again, is taking something that looks like this, something x plus a constant times something x plus a constant, and doing the first terms times each other plus the outer terms times each other. That's this one and this one. Plus the inner terms times each other. And then plus the last terms times each other. And it's the sneaky way of doing that. Not even sneaky. It's just the formulaic way of doing that. OK? When you have this, this is called a trinomial. It's also called a quadratic equation. That's what this thing is actually called. OK? It has to do with the fact that the squared term is called a quadratic and so forth. But that is actually a quadratic. Sorry, not a quadratic equation. Quadratic expression. Quadratic equation is coming up. Expression. Okay, quadratic expression. OK. So let's practice this FOIL thing a little bit. File. I'm going to say that for the rest of my life now. OK? Anybody still writing these down? No? OK. Let's practice this. All right. 2x minus 3 times x plus 5. Expand that into its quadratic expression form. hopefully you got 2x squared plus 7x minus 15. And you got to combine those middle terms. Now, did everybody want me to go through the FOIL method again? The first, outer, inner, last. OK. The first FOIL method says the first thing you do is the first two terms. I will do those terms in some other color. How about orange? OK? You're going to do the first terms in orange. It's going to be the 2x and the x. And that's this one right here. So didn't I multiply the 2x times the x to get the x, 2x squared? OK? Then you do the outer terms. And the outer terms, I'll do in blue. OK? The outer terms are going to be this outer one here and the other outer one here on the outsides of the formula. So 2x and 5. It's going to be this one and this one. OK? Then I'm going to do the inner terms for this one. Or the whole negative 3x is the one you want there. It's going to be the inner terms. It's going to be this one and this one. By the way, everybody should get 2 circles around it because we're doing each one twice. And then finally, I don't think yellow is going to show up, but I'll try it. The last one is the, oh, it is showing up. Oh, this isn't permanent, is it? One time I had the most beautiful green pen, and it was in my office. And I'm like writing, I'm like, wow, this is the best dry erase marker I've ever seen. It was just brilliant, right? And I go to erase it later, and it's like nothing. I look at the thing, it says permanent marker. Absolutely permanent marker.
Oh, really?
Yeah. You know how to get permanent marker off? If you do have a whiteboard? You dry erase over it, and that works. Kind of cool. Hand sanitizer works? OK. Anyway. So the last terms are going to be this one and this one. OK? All right. That's how we got all those terms. OK? And you do that every time when you're trying to multiply these out. What you're always going to find out with the things in this form is that you'll always be able to combine those middle ones by adding or subtracting as well. So you'll always end up with something that's like this. Now, if I said a number has factors, let's say I had a number like 28. What are the factors of 28? In other words, what is that? 4 and 7, 4 times 7, 1 and 28, 14 and 2. Anybody else? I think that's about it, right? Those are the factors. In other words, these two things multiplied by each other get 28. Can you see that the answer, or the answer we got here, has factors of 2x minus 3 and x minus 5. I know it looks a little funny up there with the, I'll rewrite it here. 2x minus 3 times x minus 5. Two things multiplied by to each other become this number, or this expression, right? One thing they make you do, and then I'm going to make you do, is go from this into this. It's called factoring. OK? And it's what we got to work on next. We got to figure out how to turn this into 2x minus 3 times x minus 5. And it's a little bit of practice and a little bit of remembering how to do factors of other numbers and a little bit of trial and error sometimes. And you eventually will pick it up. OK? But let's start to figure this out. OK? By the way, have you guys ever seen videos called a website called the Khan Academy? Khan. This class is so short that it's probably not worth trying to get there, but Khan Academy. This is an online school, basically, not even school, tutoring thing. And this guy Khan has like a zillion videos of this stuff where he describes all this stuff. And they're all videos there. And he's a really good teacher. And if you ever need to like brush up on this stuff, you go there, and it's great. But anyway, I was just saying, because you can go watch him do like factoring, which is what we're going to do, and it's probably better than what I'll do. But we'll do the best we can. OK? All right, I'm going to erase this one. OK. Tell you what, let's do this. Instead of launching right into this, let's take a break, come back at 1/4 and then we'll start this stuff. OK, I was gonna do it all at once, but I'll give you a little break. All right, I think most of us are back. In fact, 23, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're all back. OK, good. All right. Now we got to try this factoring thing. Here's what I wrote this up here just to show you what we're going to try to be looking for. X plus A times X plus B. Let's do our FOIL method on that. OK, our FOIL method. First is x squared. OK. Outer is x times b, which just we'll write b times x, like we'll write bx. Inner terms are a and x. And the last term is a times b. That's just the FOIL method, OK? What we can now do is we can just combine these two because they're the same term. So we're left with x squared plus, I'll write a plus b in the middle, a plus b times x. I'm actually doing like undistributing it, right? A times b plus x plus ab. Because I used a's and b's in here as variables, anytime we have something in this form where we have x squared plus a some constant times x plus some other constant, you can always think of those constants as something times something times something. In other words, we're going to find the factors of this. Those two factors have to add together to be this. OK? So what we're going to try we're going to be going backwards from this form to this form. And we're going to be finding factors and then making sure that they add together. OK? So let's do an example. OK? First example of this stuff. X squared plus 4x plus 3. What I'm going to tell you on the test is factor this. OK? And what you're first going to do is you're going to go, OK, I want to get something that has 2 parentheses in it like that. OK? Thinking back to the FOIL formula, the first 2 terms, to produce x squared, what are the first 2 terms going to be? X. OK? So we're like a third of the way there, right, already, just by putting that in there. OK? They have to be x. The other 2 terms, OK, the outer ones here, are going to be from the L part, the last part, something times something. For 3, which is here, what's the only thing that could be something times something? Actually, there could be 2 things for that. 3 times 1, or what? Nope, it's got to be. We're going to just do integers for now. What's that? 1 times 3, which is the same. There we go. -3 times -1 is another set of factors, isn't it? Because -3 times -1 does give you 3. So we know it's going to be 3 and 1 at least. So let's put those in there, OK? Let's say that it's going to be, I'll put the 1 there and the 3 there. It doesn't actually matter in this case. OK? If, and by the way, does 1 and 3 add up to be 4? Remember we said that we had that addition term in there? That whatever factors we found out had to add to the middle? Aha. That's good. That's good news so far. Because it's positive 4 here, which ones are we going to use? Which one of these add up to be positive 4? The positive 3 and the positive 1, which means this has to be positive 1 and positive 3. OK? And we've just factored our first thing. That's it. Now, that is it, but it just gets a little trickier when we add some more parts to it. Not really parts, when we add some more different types of examples. Let's try this one. Let's try x squared plus 2x minus 8. And I'm going to say factor. And you're going to say, I need some parentheses. And then you're going to say, hey, it's just x squared there. So I'm going to write down my x's in there, 2/3 of the way there. If you get this far on the test, I'll actually give you points for that. Right? I'll actually give you points for that, because I know that you understand that's the form I'm looking for. OK? Don't stop there, because you won't get all the points. OK? All right. Now we have to look at these two things, and we have to say, what are the factors of 8? In fact, what are the factors of negative 8 in this case? OK? We've got -1 and 8. Or, I like that. How about this? 8 and -1. Those are different factors in this case. OK? -2 and 4. And what else? 2. All right, we'll do it that way. -4 and 2. OK. So it's going to be one of those combinations. Which one of those combinations adds up to +2? This one does. So now we plug that in, -2, +4. Are we done? We're done. So that isn't too bad for these. These ones aren't too bad. You just got to remember, you got to find all the factors, and then you have to do that. And if you have something like, 144 over here, it's kind of annoying. You're like, oh no, I got lots and lots of factors. But I will try not to give you hard ones like that. OK? All right, let's try another one. Try this one, x squared minus 6x minus 7. Do it right here. X squared minus 6x minus 7. Factor it. Any other choices besides that? No. That's it. What's that? Yeah, which ones are going to be then? This one? What's -7 plus 1? -6. Right? Oh, did I write? I wrote it wrong. That's because I wrote it wrong. There you go. -1 and 7. Both of them. Thank you. Yes, the -1 and 7 would not work. So it's -7, 1. -7 and 1. And it doesn't matter which order you have these in for this one. You can have x plus 1 over here and x minus 7 over there. It doesn't matter. Did I write it wrong here? I did it wrong again, didn't I? Thank you. Is that better? Yeah, thank you. Got to let me know. Keep me honest, man. This is all on video, right? People are going to look at this and be like, that moron didn't know how to do this stuff. And his class just laughed at him. And he had all these like mean comments on YouTube. OK. All right, so that's a good one. Let's try x squared plus 8x plus 15. X squared plus 8x plus 15. I didn't even write all the factors down. This one isn't too bad.
So we don't look at factors for that 8x.
You would have to look the factors for this one. You don't have to worry about the factors for x, or the middle one. You look at the factors for this one. Okay? That's the one you look for factors for. That's because it comes out this way. You're looking for the factors of this one. You're not looking at you're looking for the addition of this one. So what adds up to 8? Well, 1 and 7, 2 and 6. This one's easier first because less factors generally than what's added with this. By the way, what if I did this and said x squared plus 7x plus 15? Yeah, I'm seeing the symbol for like doesn't exist. You can find the factors of this, but you can't do it by this kind of factoring method. They're not going to be integers. Okay, so we're not even going to worry about those. They're always going to be integers in the ones we're going to do. We are going to use the quadratic equation a little bit later to do these ones, but sometimes you'll get this. This, if it's like this is called a prime number, basically. You can't find, it doesn't have factors, or a prime expression. You can't find the factors of that. So I won't ask you those. There will be solutions for the ones I gave you, or I give you. Okay? All right. OK. So that was the easier ones. Hate to say that. OK. Now it gets a little bit harder. And it gets a little bit harder when instead of having x plus a times x plus b, we have something like, let's say, let's use some other variables. I don't know. Mx plus a times x plus b. Right? Now we're going to have some other one here. Right? And this is going to, if we do the first terms here, it's going to be mx squared plus outer, which is going to be mx plus, mxb plus inner, which is ax, and then last plus ab. Right? And now you get this extra m term in there. It gets a little bit hairier. Okay, a little bit crazier. I'm not going to don't worry about. We're not going to worry about this part of it, but it just does get a little bit trickier, because now you got to figure out a couple other things. Okay. So here's the example. Let's try this. 3x squared plus 5x minus 28. Factor this. Okay. The first two terms have to multiply together to be what? 3x squared. So we got to find the factors of this one. Yuck. Okay, what are the factors of 3? 3 and 1, which is nice. It's only 1. So you're going to have 3x and x. Okay. We kind of do the same thing as before, because the last one, okay, is going to still be the factors of 28. Okay, so let's write down all those factors of 28 again. -1 and 28. 1 and -28. Did I do that right this time? 1 and -28. Okay. How about -2 and 14, or 2 and -14? And we've got one more. How about, yeah, I'll do it up here. -4 and 7, or 4 and -7. Okay. So it's going to be one of those combinations. Right? But now what we need to do is we need to find how we're going to combine the last terms to add together with this 3 business in there. OK? What's that? How do you know? Yeah? Well, let me write down all the different combinations, right? I don't even want to, because there's a huge list, right? It could be 3x minus 1 times x plus 28, or it could be 3x plus 28 times x minus 1, right? No, it's not the same thing in this case. because the 3x plus 28 is different than this one, right? Or it could be 3x plus 1 times x minus 28. Or it could be 3x minus 28 times x plus 1. It gets a little bit tricky here. Okay? This is one where you got to practice this stuff. And you got to just kind of plug in numbers that, it's probably not going to be 28, because 28 times 3 is a really big number, and you don't have any really big numbers in here, so it's probably not going to be this one, right? And this is where the guessing and checking part kind of gets in there, okay? I could write down all the different other combinations too. There's all these combinations of this thing, right? If you write enough of them down, you'll actually come to 3x minus 7 times x plus 4, which is, I think, what Oliver said, or no? 3x minus 7 times x plus 4. Okay, let's at least check that and see if it works. Okay, same thing there. Okay, let's see if that works. First, 3x squared, outer plus 12x, inner minus 7x. Is 12 minus 7 5? We're good to go then, right? Minus 28. Okay, so that actually, so it works that way, but we would have had to write down all those different combinations. This is just where it takes some practice. And I'll admit, I was never very good at these things. You just got to try to come up with all the different factors and start plugging in and trying, and eventually you'll get to the right one. And I'll give you enough time to do it. It just can get a little frustrating. Okay, so let's try one, and I'll let you chug away at it for a little bit. Try this. 5x squared minus 24 plus 28. This already looks ugly. Okay. 5x squared minus 24x, thank you, plus 28. Okay. The good news is we don't have to do much with the 5, because we know that's going to be there. If this was like 12x, it would be the ugliest one you've ever wanted to do. I would say do it with a different way, because that would be ugly. One, 28, 2, 14, 4, 7. All those combos. Did you get it?
No.
Oh. Tell you what, don't worry about these ones yet. Focus on these ones first. So what you might do is you might say, OK, I'm probably going to not do start with the 1 and 28, just because of the big numbers and blah, blah, blah. OK? The 2 and the 14 is also kind of big numbers. But then again, I'm going to be multiplying something by 5. So maybe, hey, look, 5 times 2 is 10. And 10 plus 14 is 24. Aha, that might be something good. OK, let's try that one. If we're going to have the 2 times 5, where's the 2 have to be? Here or here? Got to be over here, right? Because you never do these two terms times each other. 14. OK. If it's going to be negative 24, well, what's 5 times 2 is 10, and 14 times 1 is 14. That would both be positive. Is it going to be a negative and a positive and positive? Well, it's not going to be a positive and positive. Is it going to be a negative and a positive, or a negative and a negative? It's got to be a negative and negative. Forget about what adds up to each other. What's this one have to be? Positive. So what's the last term? The last two have to be the same term. So when you multiply them together, you're going to get a positive answer. So now this one should work out. 5x squared first, outer minus 10x, inner minus 14x, last positive 28. 5x squared minus 24x plus 28. OK. We could have tried the 4 and the 7. In fact, if I didn't have a piece of paper in front of me, I might have said, well, let's try 4 and 7. But even 4 and 7, 20 and then 14. Can't really get 24 from that. How about 35 and 8? You can't really get 24 from that either when you're adding together. So it's it had to be this one. Trial and error sometimes. Okay. Questions on that? All right, we'll do practice on that, and your homeworks this week, do have practice on that stuff. All right, questions on this? All right. OK. You can actually solve, we've been doing quadratic expressions. You can solve quadratic equations using this factoring method. If you have something that's ax squared plus bx plus c, in other words, there's an x squared term, there's an x term, and there's a constant term. There's some number, constant number in front of the x squared. There's some constant number in front of the x. Could be 1, also could be 0. And then there's a constant term over here. Equal to 0. Okay? This one can't be equal to 0, by the way. That is called a quadratic equation. Question for you. A times b. If a times b equals 0, doesn't either a or b have to be equal to 0? One of those ones has to be equal to 0?
Yes.
Good. If we can find the factors of this, then we can use this fact to get rid of one of them and solve for that equation by itself and figure out what the answer to x is in this case. And this is really what we're trying to get down to. The whole point of this whole quadratic equation stuff is figure out what x equals in this form. Okay? So the key is that if a and b equals 0, a times b equals 0, then if a or b equals 0, then the other one, then you can use that fact to find the other one. And I'll show you what I mean. Okay? Let's look at this. X squared equals negative x plus 6. Is this in this form? If you move it over, it is. But right now, is it in this form? It is not, because there's no 0 equals 0 on the end, and there's terms not together. Let's make it into that other form. What's the first thing I might do? Move the x over. So if I add x to both sides, I get x squared plus x equals 6. Are we in the form yet? No. Minus 6 both sides. I get x squared plus x minus 6 equals 0. Now is it in that form? Aha! Factor this. Actually, I'll even leave the 0 in there. Just factor this one.
It could be the other way though, right?
Could be the other way. Yep. Once we have this factored like this, now we can use this idea that if a times b equals 0 and one of them equals 0, the other thing is still true. Okay? Let's make this one equal to 0. Okay? Well, yeah, in this case, we'll say that if this one was equal to 0, we can say now x minus 2 equals 0. Can we solve for x using just that? Add 2 to both sides. X equals positive 2. There's one thing that works. All I did was I said, forget about this term. Let's look at this term. Now I'm going to say, forget about this term. Let's look at this term. X plus 3 equals 0. In other words, x equals negative 3. Okay? The only thing people, the one thing people always forget on this is they look at this and they say, oh, it's x equals negative 2. But it's not. It's x equals 2, because you have to remember to do this back into the x equals 0 business. Okay? So let's see if it makes sense, if it works. If x is 2, and we're going to plug back into this top equation here. If x is 2, then 2 squared equals negative 2 plus 6. Does 4 equal 4? Sure it does. That one works. Let's see if negative 3 works. Negative 3 squared equals negative 3 plus 6. Nope, negative 3 plus 6. Sorry. Negative 3 plus 6. Negative 3 squared is 9, equal to negative 3, which is positive 3, plus 6, 9. Good to go. Okay? So that's how we're going to have to solve these things. So let's do another one. Let's do another one. Let's look at 5x squared. Oh, you're going to hate me for this one. 5x squared, it's got one of these ones in it, plus 54x plus 40 equals 0. Solve for x using by factoring.
What was the answer in the last one? 2 or negative?
It was both. So if you were to write, that's a very good question. Thanks for asking that, Zach. The answer to the last one would look like this. X such that x equals, what was it, 2? And x equals negative 3. I think in the homework, I think what you're going to do is you're just going to, it's going to have this like stuff in there. You're just going to put 2 comma negative 3. I think that's what you're going to do for the homeworks. So you're just going to have to type in 2 comma negative 3 for both answers. And by the way, that's a common property of quadratic equations, is that they have 2 answers for one value of, or that they have 2 answers that fit in there. Okay, factor this. All right, let's see. I like this one right off the bat. Yeah. I know I just wrote it in there. Want me to walk through how I figured that out? The factoring part? I wrote down all the factors, and then I started thinking about it, and I said, this is before we got to here. I said, OK, I'm going to have to multiply one of them by 5 and one of them by 1. And then they have to add together to be 54. Well, 40 times 5 is 40, and 1 times 1 is 1. That can't add up to 54. 5 times 20 is 100, and then that's not going to do it. How about 2 times 5 is 10, and 20 times 1 is 20. 20 plus 10 isn't going to get to 54. 4 times 5 is 20. 10 times 1 is 10. 20, that's not going to work. But 10 times 5 is 50, and 1 times 4 is 4, 54. That does work. That's why I went, aha, that looks like the one. And then you go, OK, which one gets to be multiplied by the 5? It's going to be the 10. So the 10 has to go over here, and the 4 has to go here. And the pluses and minuses, well, it's all pluses, so that makes it pretty easy. But 4 times 10 has got to be plus or minus, but it can't be minus because of the positive. You can't add 2 minuses to get a positive, so it's got to be positive. Okay. All right. Now that we do this, we say ignore one of them and do the other one. 5x plus 4 equals 0. Subtract 4 from both sides. We get 5x equals negative 4. Divide both sides by 5, and you get x equal to negative 4/5. Not quite done. That's one answer. The other answer is we're going to ignore this one and do this one equal to 0. X plus 10 equals 0. Subtract 10 from both sides. You get x equal to negative 10. There's your other answer. So the answers are, you could do it in this form too. Negative 4/5, comma, negative 10, curly brackets like that.
You don't have to write down that whole thing?
Nah. I think it'll do it on the homework. It'll put it like, it'll have a little space. You just have to do negative 4/5, comma, negative 10. I think so. Let me know if it doesn't work that way. OK. Questions on the? What's that? How to get the 4/5? 5x plus 4 equals 0. Solve for x. Right? I subtract 4 from both sides first, and I get 5x equals negative 4. 5x equals negative 4. Then how do I get rid of the 5? Divide. Because it's being multiplied, now you're dividing it away. Divide by x. So now that is going to go away, and you're going to be left with x equals negative 4/5. OK? Whew. All right. OK. So this is how to do the factoring by hand like this. OK? There is another way to do a lot of this stuff. Okay? If you have an equation in that form that I gave you before, in other words, ax squared plus bx plus c equals 0, there's an equation you can use, a formula you can use, to figure out what the values of our x are, otherwise known as the roots of the equation. Okay, I mentioned that a couple weeks ago, the roots of the equation. Okay? To do this, there's a formula. I'm not going to derive it for you. If you want to do the derivation, we can do it. Say after class, we'll go through how to derive it for you. But the bottom line is, if you have something in this form, you can always do the following. You can say, straight off, x equals negative b, which in other words, whatever b is, you put it there. Then this weird thing called plus or minus. Remember how there are always two answers to these? This is where the two answers comes from. It means one way you're going to do plus what comes next. The next time you're going to do minus what comes next. And there's your two answers. Times the square root of b squared minus 4 times a times c. In other words, whatever a is, this goes here. Whatever c is, this goes here. Divide the whole thing by 2 times a. Okay? This is called the quadratic formula. And it makes it, instead of doing all that like trial and error stuff, you just go, you put it in your calculator, and you do this. You type all the numbers in. You don't even have to, I mean, you'll get to the calculator eventually. The plus or minus, you got to do this twice. You will actually get two answers. One will be negative b plus the square root of b squared minus 4 times a times c divided by 2 times a. And the other answer will be negative b minus the square root of b squared minus 4 times a times c divided by 2a. And there's your two answers. And you put a comma there, and you put them in parentheses, and that's where you're going to end up typing into the answer. You're not going to type all this stuff. You're going to type a number. A lot of times this will end up being radical and stay that way, but that's OK. Now, one of the things about this class, you have to memorize this thing. OK? Write it down, memorize it. Why? Because they don't put it on the stupid formula at the end of the year. There's a formula sheet. I guess I didn't tell you that. There's a formula sheet. It's like 1 page, maybe 1.5 pages. And it has a bunch of the formulas that we get to later in the class, right? Get to later in the class on it. This one is not on it. But they do ask you to use this on the test. So you got to memorize this. We'll do it enough times that you'll do it. You'll memorize it. If you go to YouTube and say quadratic equation formula song, there's like lots of songs that people have to memorize it. There's like quadratic equation raps. There's, I mean, you know, there are ways to memorize this thing. OK? There are probably like 100 different videos on how to memorize this thing using songs or mnemonics or something, right? Okay? But let's do an example of how we're going to use this. Okay? I will not erase. I will erase starting down here. This one I'll leave for right now. Okay? OK. All right, so here's our example. We already did this example, I think, before. X squared equals negative x plus 6. Is it in the right form? Not yet. Let's get it in the right form. We did it before. I'll just go through it verbally and then write it down. Add x to both sides and subtract 6 to both sides. And you get x squared plus x minus 6 equals 0. Somebody yesterday was worried that the little invisible ones on here, they become really important for this formula. This happens to be a 1 invisible, and this happens to be a 1 invisible. A in this case equals 1. B in this case equals 1. And C in this case equals negative 6. One and negative 6 becomes a plug and chug now. X equals negative b, negative 1, plus or minus the square root of b squared, 1 squared minus 4 times a, which is 1, times c, which is negative 6. All divided by 2 times a, which is 1. And now it's just about, now it's all numbers. You just go boop and figure it out, right? X equals negative 1 plus or minus the square root of 1 squared is 1. I'll do it right here. 1 minus 4 times 1 times negative 6 is 24. So it's minus 24. Like, nope. It's minus negative 24, which is plus 24. So inside here becomes 25. Divided by 2 times 1 is 2. OK? And let me use this space again over here. Our two answers are negative 1, x equals negative 1 plus the square root of 25, which is 5, divided by 2. What's negative 1 plus 5? 4. 4 divided by 2 is 2. The other answer is negative 1 minus 5 divided by 2. What's negative 1 minus 5? Negative 6 divided by 2 is negative 3. There's our answers. X equals 2 and x equals negative 3, which, if you go back, is exactly what we got before. Okay? You will have to do the actual factoring. You can always check it with this if you want. Factoring is most of the time faster than doing this. Sometimes it's not. If you have scary numbers, if you have like big numbers in there, just plug it into this thing and go. You got to get used to doing these things on your calculators too. Okay? 2 and -3. All right. Let's do one that you wouldn't want to factor. Oh, actually, one that we already did that we factored. But you wouldn't want to factor it anyway. You guys still writing these ones? A couple still writing this? Let's do the example before where we had 5x squared plus 54x plus 40 equals 0. This is what we're going to be doing. 5x squared plus 54x plus 40 equals 0. Oops. 2. Okay. This is A. This is B. This is C. I feel like I'm going to have to hand out calculators for these ones. Got one there, you got one there. Is that yours or you? You got yours, okay. Let's see. I think I'm going to need one more calculator. Can you guys share for right now? Okay, you got a calculator. You got yours. You need a calculator. It's a what? It is a bit tricky to type in. Don't worry about the plus or minus part. You're not going to be able to type that one in. That looks good. Yeah. Yeah, that's actually formats really nicely on your thing too. What happens when you hit equals?
It came up -4/5.
Good. And then can you go back and type in just the part that's changed, the minus to the plus? Plus to minus. You sure? I bet you can. Did somebody else bring a calculator that didn't have one yesterday?
I have an extra.
Oh, you have an extra. Awesome. Here you go. Who else didn't get one? Calculator. Great. Okay. Hey, Jeremy, you could have simplified it more instead of typing it all in. If you wanted to. 54 times 54. It doesn't make sense. Hang on. What did I do wrong?
Yeah, that's right.
Is that right? 20 times 40 is 800? Yeah. Equals -54 plus or minus square root of let's see, square root of 2,000. 20, 46 is it? I didn't do that in my head. He told me. I wish I could do that. I wish I could do that in my head. Equals -54 plus or minus 46 divided by 10. X equals. There we go. All right. Okay, this stuff takes a little practice, but it's not impossible. And you just got to remember the formula, how to plug it in, and make sure you get it in the right form. If you forget to put it in the right form, you're shot. Yes.
After you did negative 54 with the 2960 minus 800,
Yes.
what was the next step after that?
I just subtracted those.
That's
That's
it?
it. 2116. Getting this stuff? Good. And then, in order to do this, you do the plus first, and then you do, so 54 plus 46 over 10, which is what, 100? So the answer is, one of the answers 10? Then 4/5? Yeah, negative 4/5. I'm afraid the homework might ask you to simplify all fractions. Sorry. By the way, I did give you points for that one. So. Questions on this one?
Once you get to the 2116, all right, what's the
Take the square root of that number on your calculator. There's a square root button that you hit first. So you hit second, and then the button that looks like square root that has a little square root symbol on it. And then do 2116. Hit C. And then do the square root button, second and then square root. And then do 2116 equals 46. Yeah. Sometimes you won't be able to. You'll have to reduce this using all those reducing things we did, like for yesterday's test. All this stuff builds on each other. That's what's tricky about it.
So if you reduce it and you take it out, you add it to the 50.
Yeah. So I reduced. It is 46, right? Now you're going to have 54 plus 46 divided by 10. And 54 minus 46 divided by 10, and those are your two answers. Okay.
Can you give it in a decimal form?
Can you give it in decimal form? I think for the homework you probably won't be able to. I would be happy to accept the decimal form on the test. Yeah. Yeah. But in the homework, I don't think you can. Maybe for some of them you can. Okay. Do you want to try another one like this? Okay. People still writing this one down? We good? All right. 2x squared equals 8x minus 5. 2x squared equals 8x minus 5. Squared equals 8x minus 5. Solve using the quadratic equation. 4x. Enter. Yes.
After you get this right here, divide by 2, because I'm
Yep.
still working on the first one. What do you do with the 2?
First you do the top part, then you divide by 2. So negative 1 plus 5 divided, what's negative 1 plus 5?
Oh, okay, gotcha.
4.
Yeah.
4 divided by 2 equals 2.
There we go.
Yeah. Good.
Got it.
Good. Don't forget that b is negative 8.
Why?
Because you have to put it in this form, first of all.
Yeah.
And constant before the x is this whole negative 8 part. Not just plus. It's really, remember, this is plus whatever this is. Well, plus what? Plus negative 8x.
I put 2x plus 8x, not minus.
Ah, when you subtract both sides by 8x,
Yeah.
you get it in minus 8x, right?
Yeah.
Yeah. Getting there. Actually, let's do this. Divide everything by 2. How's that sound? 4 plus or minus square root of 6 divided by 2. There's your answer, because I had to reduce it all. So here's what I would type into the computer. I would type, let's see. Well, you could also do one other thing. You could also make it 4 divided by 2 is just 2 plus the square root of 6 over 2. Ugh. I hope it doesn't ask you to do that like that. I really hope it doesn't. If you type your answers in like that, I'm going to accept it. So I'm going to accept 4 plus square root of 6 all over 2, comma, 4 minus square root of 6 all over 2. Or you could do 2 plus square root of 6 over 2, comma, 2 minus square root of 6 over 2, like that.
Teacher, I'm just here. I got everything down.
Good.
Okay.
Yep.
Now, from here.
Okay, from there,
Okay, I know that.
that's right, that's, you got to here,
Okay.
okay? Well,
Well, you
2 goes
divide
into
by
that,
2.
and 2 goes into that, and 2 goes into that.
Yes.
So you can divide everything by 2. You can't divide the inside of the 6 by 2, even though it looks like you can. You can't. So you're left with 8 divided by 4. Well, 8 divided by 2 gives you 4. And 2 divided by 2 gives you nothing. And then you're left with a 2 at the bottom and a square root of 6. I know. This is just that arithmetic stuff.
I just trying to understand this.
I know.
So you divide this. And divide this.
Yeah. OK. Christine looks like she's not happy with this.
I don't get what happened after you got 8 plus minus.
Yeah.
2 to the 6 over 4.
OK. Here, let me erase this. So everybody get to this. Does everybody follow it so far where we got x equals 8 plus or minus, well, 2 times the square root of 6 over 4? You got that part? OK. So you got to that part. Now, all I'm saying is we can reduce this more. Because 2 goes into 4, and 2 goes into 8, and 2 goes into 2. I'm sorry. Well, 2 goes into all, yeah. 2 goes into 4, 2 goes into 8, 2 goes into 2. So if you divide out all those terms by 2, you'll get 8 divided by 2 gives you 4. Plus or minus 2 divided by 2 is 1. So you're just left with the square root of 6. And then 4 divided by 2 is 2. Purists would now say, I'm going to take this term and this term separate to each other. And I'm going to divide both those terms by 2. And I can get 4 divided by 2 is 2 plus, well, you can't do anything with that. So it's going to be square root of 6 over 2. You could do that as well. So it gets a little ugly like that. OK. Did I?
Yes, -8.
Hang on, plus or minus there.
It's -8 plus or minus square root.
Ah, negative -8.
Oh, okay.
Yeah. The negative 8 means it's going to be plus or positive 8. Yeah. Because the b term coefficient is -8. OK. All right, a lot of stuff. Let's take another break. Come back at 25 after. And then we'll finish up with some graphing, real graphing this time. OK. A lot of talking at you tonight. I'm sorry. You just had 3 big things to cover. And that quadratic formula thing's a long one. The next thing we're going to start working on is actually chapter 7. So 7.1, which is called graphing, and these things called functions and functions. OK, graphing and functions. OK. We have what graphing allows us to do is to draw pictures of all this algebra stuff. OK, and you say, well, what if I don't want to draw those pictures? I like the algebra and the numbers and things. Well, too bad. You're going to have to draw them. Algebra, we've already seen a lot of word problems, right? What we're going to do now is we're going to be able to graph these things and use the graphs to help us figure out some answers and to visualize this stuff a little bit better. OK? All right. Here's what we're going to have. We're going to have a graph. Looks like this. OK? This is called a Cartesian coordinate system. Cartesian. Don't worry about the thing of that. Technically, it should have little arrows on all these things because it goes off to infinity. OK? This is the x-axis. This is the y-axis. OK? This little part here is called the origin. It happens to be at coordinate 0, 0. This is called quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay. It also normally has little tick marks for the numbers. Like this. And they're labeled. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Negative, 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 negative. 1, 2, 3, 4, 5, 6, 7, and all the negatives as well. And there we go. You have to, what's that? On the right side. The homework builds these things for you, and then you have to use this little formula or this little your mouse and draw stuff in sometimes and plot points. It'll say like plot 5, 1. So if we want to plot 5, 1, this is the x direction. This is the y direction. And here's how you do it. You go over 5, 1, 2, 3, 4, 5, and you go up 1, and you put a dot there. And you'll have to do that on some of the homeworks. So figure that out. If you have trouble, let me know. I don't think it's impossible. They do teach you how to do it, but that's it. So I just plotted 5, 1. And normally what you do is you'll plot it and then put 5, 1 next to it like that. If I want to plot -2, 3, same thing. I go x first, -1, -2, and then down 3. 1, 2, 3. No, sorry, up 3. 1, 2, 3 because it's positive 3. That is -2, 3. -3, -7. -3, -7. 1, 2, 3. Now we go down. 1, 2, 3, 4, 5, 6, 7. Right there. -3, -7. OK? That happens to be in quadrant 3, et cetera. Questions on the graphing? OK. Hopefully you've seen this stuff before. I will leave that up right now for right now. Graphs, we can graph equations. OK? And you can graph them. The types of equations we're going to have are going to have two variables, an x and a y variable. So you might have something like y equals x squared minus 3. And we're going to figure out how to graph that. OK? This could represent lots of different things. This could be the fuel economy based on how fast you're going. You know, there's a speed at which you can go in your car that's the best gas mileage. And it's not 1 mile an hour, and it's not 100 miles an hour. It's somewhere in the middle there, right? A lot of cars, it's like, I don't know, 28 miles an hour or something like that. There are people who drive their cars specifically with the purpose to save as much gasoline as they can. And they always drive right at that speed. And they always roll through stop signs. And they're supposed to follow all the laws. But there's like people who compete in this thing. People drive like 450 miles or 500, 600 miles on one tank of gas by doing this stuff just because they can do it. And they can't like put more gas tanks in. Right? It's all based on how much total fuel. It's pretty cool. But anyway, this formula, the equations like this can represent a ton of things. OK? The solution to this, and there's lots of solutions to this. In fact, there's an infinite number of solutions to this. But a solution is just an ordered pair like this. OK? That could be a solution to this. In fact, let's figure out what something is. If we had x equal to 2, what would a solution to this be? In other words, figure out what y is by plugging in x equal to 2. Okay, if we had x equal to 2, then y equals 2 squared minus 3. 4 minus 3 is 1. So a solution to this is 2, 1. Okay? And you can plug it in. Is 1 equal to 2 squared minus 3? Yes, we just did it. Right? So that's the way we can do this. We can figure these things out. The graph of this equation is the set of all points that match this criteria. It's an infinite number of points. And obviously, we're not going to draw an infinite graph on here. But we're going to draw as much as we can fit onto our chart. The first way we're going to do this is we're going to do a little table for this sort of thing. Okay? So because I don't want to draw all this graph again, I'm going to erase the points on this one. And I'm going to erase the quadrant designators there, too, and the little origin thing, just for now. Okay? And we're going to start with this. And I'm going to do a little chart. How about I do the chart? I'll do the chart right in this little piece right over here. Okay? So let's say we have an equation that is y equals x squared minus 3, which is the one we just did. All right? X squared minus 3. And let's do an actual chart with this, starting with x here and y here. And we're going to do a bunch of values that will fit onto our chart. Let's start with -3, -2, -1, 0, 1, 2, and 3. OK? Let's write out the first couple of these. We don't have to do them all. -3 squared minus 3 equals 9 minus 3 is 6. -2 squared minus 3 equals 4 minus 3 is 1. -1 squared minus 3 what's that? -2. 1 minus 3 is -2. 0 squared minus 3 equals -3. I guess we will write them all out. 1 squared minus 3 equals -2 again. 2 squared minus 3 equals 1 again. And finally, 3 squared minus 3 equals 6 again. OK?
How you pull that shit?
Okay. This is graphing. This. OK? Well, this is just figuring out the table part. Now let's actually plot all these. So we're going to plot -3, 6, -1, -2, 1, -1, -2, 0, -3, 1, -2, 2, 1, and 3, 3, 6. OK? Let's do it. -3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Here. -2, 1. -2, 1. There. -1, -2. -1, -2. Here. 0, -3. Here. 1, -2. 1, -2. Here. 2, 1. Here. And 3, 6. 1, 2, 3, and up 6 here. And this is where you get to do kind of something fun. You get to connect the dots. Now, where did my yellow one go? There it is. This actually showed up pretty well before. So what we're going to do is we're going to connect the dots. Turns out, let's see if I can do this. I missed that one a little bit. You don't have to worry about the details of this. Arrows on the end because it goes on forever. What is that form called? That is a parabola. Okay? A parabola. Okay? Yep. And it looks like that form, and it's always going to look like that type of form if you have something that looks like this form, x squared minus 3, or something squared minus something else. Okay? This is called the point plotting method. Point plotting method. Okay? And it takes a little bit of time, but it's pretty straightforward. Okay? If you have it in the right form, you're going to be good to go. Okay? All right. Let's try one of these. Let's say this one was a parabola one. Let's do this. All right. Let's say that we're going to use this to solve our little a problem here. Let's say you're going across a bridge. Anybody ever been across the Bay Bridge in San Francisco? Golden Gate Bridge too, but the Bay Bridge. I once drove up to San Francisco. I needed to go to a meeting in San Francisco. I get up to San Francisco. I was totally lost, but I had a little map. And I'm going around, and I need to take an off ramp. And I'm in downtown San Francisco, and I go, and I miss the off ramp or whatever, or the turn. Next thing I know, I'm on the Bay Bridge. This is like a 2-mile long bridge. Yeah, you go through Treasure Island. I get to the other side of the bridge, and I'm like, oh man, what am I going to do? Well, I don't have any money to pay the toll coming back. It wasn't a toll going that way. Coming back is a toll. So I go to a cash machine, pull out my wallet, no ATM card. And then I'm thinking to myself, it's going to take me 2 hours to go all the way around some other way. It's just not worth it. I'll miss this whole meeting. I ended up having enough change in the little center console that I handed the lady a bunch of quarters and things and dimes, and she wasn't happy with me, but I made it back. So, okay. So here's, I guess I'll have to erase this. I'll draw it again quickly later. Here's a toll booth toll question. Okay. the toll to cross a bridge. Toll to cross a bridge is $3.50. You can buy a monthly pass. A monthly pass for $20, but the monthly pass, you pay $20, but you also pay $1 per toll. I've never seen that system before. I think that's crazy. But you can either do $3 each time or $20, OK? The question is, well, we've got a couple questions. First of all, let's just write down what we've got. The monthly cost, we'll call that y. And you'll see why we use y in a minute, of using the bridge, x times is given by y equals 3.5x. Right? Because it's 3.5 times however many times you go by the thing, OK? So y is the number of the cost equals 3.5x. If you have a pass, this is with a pass, OK? And it's equal to 20 plus 1 times x, or just x, 20 plus x with no pass. Right? So far, so good? First thing I want to do, A, make a table. Make a table. Second thing we want to do is graph the equations. And then the real thing that we're trying to find is find where they intersect. Yeah, thank you. This is no pass, thank you, and this is pass. Yep, you're right. Thank you. Okay. All right. So we're going to do two charts. Okay? And doing these charts, you kind of, if you're going to do the graphs, I'm going to erase this just so I have more room. When you do this, you kind of got to guess good points. Because otherwise, you'll go off in the middle of nowhere, and then it won't be quite as easy. But let's do the graph without the pass. Without the pass. X and y. OK? So let's pick x values. Just go up by 2. We'll start at 2, 4, 6, 8, 10, 12, and 14. If that's x, what's y? With no pass, 3.5 times that. 3.5 times 2 happens to be 7. Right? Is that right? Yeah, 3.5 times. And then 14. I'm going to do these so we don't have to sit here and talk them out. But 21, 28, 35, 42, and 49. All I'm doing is 3.5x. Okay. With the pass, we're going to have the same thing, x and y, which in this case is 20 plus x. Well, this is pretty easy. 2, 4, 6, 8, 10, 12, 14, 22, 24, 26, 28, 30, 32, 34. Everybody agree with that? OK. So we're going to look for points, or we're going to graph points 2, 7, 4, 14, 6, 21, et cetera, on my little graph right here. I'm going to do the best I can on this. OK? X, y, and arrows. And actually, I guess I don't even have to put the negative part at all, because there's no negative numbers on here, are there? I'll do it this way. I'll make it a little bit easier. I will do it like this. There we go. X, y, 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. If you're drawing these graphs, you really should label them as best you can. And then we're going to go all the way up to, what's our biggest number here? 49. Let's go up to 50 by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Not very even. 15, 20, 25, 30, 35, 40, 45, 50. And by the way, my scales don't look the same either, because this much is 14, and that same amount's like already up to 30. So not the best way of graphing, but right now it'll be all right. OK, 2, 7, 2, 7. And you do the best you can on these as far as graphing goes. 4, 14, about there. 6, 21, about there. Notice this is a nice straight line. If you do it right, 8, 28 in this case. 28, about there. 10, 35, there. 12, 14. 12, 42 rather, about here. And 14, 49. 14, 49 is about there. And I missed that one by a little bit. And I didn't quite do these either. Didn't spread them out quite enough, but we'll call it like that. And then this should be a nice straight line if I was to do it right. OK, those would be straight if I was doing this on graph paper. OK, and this one with no pass, without your pass. OK. Okay. And the other one, 222. 222. Let's see. 222. 424. 424. 626. There. 828. About there. I should do this in a different color. 1030. About there. I'm getting all goofed up. 1232. About there, and 1434, about there, let's say. And I'm going to do this in a different color. And this one should be something like there. OK? So if I had used a ruler and used proper graph paper and everything, that's what it is. And this is the one with the pass. OK? That's the one with the pass. All right, well, they cross somewhere. Actually, they happen to cross at 828. Okay? Meaning that if you're not going to do more than 8 trips in a month, well, just pay the toll. If you're going to do more than 8 trips, buy the pass and pay $1 per toll. If you're going to do exactly 8 and you happen to know that beforehand, it doesn't matter. Okay? Questions on those? All right. OK, we're getting there. Next thing, if you didn't get all this down, I think they do this example. I'm almost positive they do this example in the book. But you'll have to check. Yeah, OK. All right. When I say that something's a function, I'll leave the numbers up there for now. When I say something is a function, okay, that means something very specific in math. If something is a function, it has only one value of y for each value of x. Okay? For every one of these, there's only one of these. There can be more values of x that give the same value of y. Okay? But there can't be more values of y that give the same value of x. I think I said that right. I think I said that right. Okay? Rewrite functions like this. F of x, y equals the function of x. We've been dealing with functions. This is a function, y equals 3.5x. That is a function of x. Okay? And what we say is y equals f of x, a function of x. Okay? So we could have said for this, we could have said f of x equals 3.5x. Okay? If we wanted, we could say, what's the f of 10? That just means plug that in here. In this case, it's 35. Okay? That's what we mean when we say f of x, function of x. Okay? So let's take a look at one of these. I'm going to erase this now. Let's take a look at an example as follows. Here's a function, f of x. f of x equals 0.0875 x squared, we can have squareds in there if we want, minus 0.4x plus 66.6. Why would we use that? Well, this models a car's stopping distance in feet on dry pavement if you're going x miles an hour. In other words, if you're going 1 mile an hour, it will take you this many feet, 0.0875 times 1 squared minus 0.4 times 1 plus 66.6 feet to stop. I don't believe that if you're going 1 mile an hour, but that's what they say. Okay. Let's find the required stopping distance at 20 miles per hour. Well, we've done all these things before. We did this for like a bunch of times before. Function of 20 is 0.0875 times 20 squared minus 0.4 times 20 plus 66.6. For 20 miles an hour, if you did all that on your calculator, you would get 93.6 feet. Okay? Actually, it might have worked for 1. I'm not sure. It might have worked for 1 because you're subtracting in there. But anyway, 93.6 feet. Okay? That's all we need to know for that sort of thing. We can also graph functions. We would just have the same exact table. Instead of y, we would use f of x. Okay? All right. If we want to figure out if something is a function, we can do this thing called a vertical line test. Which way is vertical? This way or this way? This way. Vertical is up and down. Okay? Good guess. 50-50 chance. You chose poorly. All right. Okay? If the vertical line that we are about to draw touches a graph in more than one point, it is not a function. So, for instance, say you have a graph that looks like this. Draw a vertical line down there. Does it touch the graph more than once? Mm-hmm. It does. Not a function. A circle is not a function. Not a function. Exclamation point. Okay? How about something that looks like this? If you draw a vertical line there, does it touch it at more than one point? No. Nope, just right there. There, there, there. You can't get any one line to touch at more than one point. Function. OK? How about this? Is that a function? No, not a function. What if I just moved it so it wasn't on the x-axis or the y-axis like that? Still not a function. You can draw a line down and it touches more than one point. Okay? So again, let's look at what this means. For every value of x, there can be only one value of y. In other words, you go over to the y-axis. If you ever get a point where there's two values of y for that graph, it's not a function. If you look at this one, this value right here maps to this value of y there, right? Okay? But guess what? This value also maps to that same value, this value of x. So you can have more than one x have a y value that's the same, but you can't have more than one y value for the same x value. Okay? That just means it's a function. Why is this the case? You'd think the math would work either way. Sure, it does, but we're gonna leave it in these forms so that we can deal with things like dividing by. You don't need to ever divide by 0 and all that stuff for functions. Okay, you run into other problems if you didn't define it that way. All right. Okay. Let's see. I think at this point, I will give you some practice, and then we'll do that for the rest of the time. I know it's a lot of stuff tonight, but I'm going to hand out two things. I'm going to hand out the practice test for next week. The answers are online, and I'm also going to hand out this little worksheet. And I have to give you one change to the worksheet. They actually did one of the problems wrong, and it couldn't be solved. So that's that. All right, this is the test. Actually, I'll just let you hand that out.
You gave me one already.
I did give you one already, thank you. I think you might need one more. And this is the worksheet. When everybody gets that, I'll give you the question.